Hello, welcome to our software development training, lesson 5. Today, we are treating a very interesting topic. It is a subject that is considered one of the lifeblood of every software developer. Source codes, Git and GitHub. My name is Jojo Encho. You ready? Let's proceed. What you should expect today. In today's lesson, I'll do a brief recap of what software development is all about. And then we take a look at what we call source code. From that, we will come to understand what is open source and then source control. And finally, we will look at Git and GitHub. And as usual, we'll have some time for questions and comment. Okay? Software development. As I have already stated in previous lessons, a software is a collection, a series, a number of instructions or what we call codes that work with data to determine what the computer should do at any point in time. That is, we have codes that are written and it follows a certain defined pattern we call algorithm and uses data to tell the computer what to do. Now, software is created by professionals we call software developers or software programmers. These programmers write series of instructions or codes and determine how this code should use data to control the computer system. Now, for every piece of software, the writing of codes takes some time depending on the functionalities involved. Usually, it also involves a number of software developers working on the same piece of software. Therefore, multiple software developers can contribute on the same software, each of them writing his or her own instructions as part of the same software. The codes are normally written in files, and these files are stored together in folders or directories. In actual sense, a software is a number of codes written in a file. These files stored together in folders, and then they work together following a particular pattern or algorithm to get some work done. That is software development. Writing series of instructions, adding data, and letting those instructions follow a specified pattern to get work done. I hope that is clear. Let's move on. Now, the series of instructions or the codes that are written to get the software done is what we refer to as source code. Let me repeat that again. Now, the list of instructions, or let's call them commands, or the text that software developers create to make a software is what we term as source code. That is to mean that it is the source containing the code from which software is made. The source containing the codes from which software is made. In our previous lesson, we made mention of programming languages. We said that the computer has a specific language it understands. Humans, we also have our languages that we understand. These two languages are different from each other. For humans to be able to communicate with computers, then there should be a bridge between human languages and computer languages, as some sort of interface, hence the need for a third form of language. Let's call this language programming language because that is the language humans use to program the computer. We have discussed about this in earlier lessons. I will urge you all to find our previous lesson to understand what we said on programming languages. Nevertheless, you can do more research online to find more about programming languages. But today, our concern is how programming languages create source code and how these source code are converted into computer languages or converted into form that the computer can understand. So, we use programming languages to create the commands, the codes, the source code that make up a software. Generally, we can group this source code created by the programming languages into two main categories. That is to say, we have the source code that are compiled into executable codes that the computer can easily run before packaging it as a software. What am I saying? I'm saying that certain programming languages create source code that are compiled by the developer using certain compiling engines or certain other softwares that does the compiling into executable code. That is a code that the computer can execute to get work done. So that source code from the development environment or IDE, they are compiled into another intermediate form of code we call executable code or files. And then the computer pick these executable files and run them as software. That is what we call compiled code or codes from compiled programming languages. That is right. Okay. Now, at the other hand, we have other source code that are not compiled by the developer per se. However, the code are carried raw as the developer creates them into the CPU for the CPU to interpret. This kind of code or this kind of programming languages are what we term as interpreted languages. They are interpreted in the sense that the codes are carried directly to the CPUs to interpret them. Most often, the interpretation is done at runtime. That is, they are interpreted on the go whilst the software is being run. Okay, the difference is compiled languages, right after development, you move ahead to convert them from source code into executable code. And then the computer reads them and understand. Now with interpreted languages, you move the raw source code into the CPU and the computer will interpret them. The interpreted languages are often referred to as scripting languages. So most often, some developers refer to that kind of source code as script. Even there is an argument that scripting languages are not programming languages, and that only compiled languages are true programming languages. However, for now, what I will say is that a programming language is any intermediary language between human language and computer language that humans use to write a piece of computer software or computer program. So for now, we will group both compiled languages and interpreted languages under computer programming languages. Now, you may be wondering that from the examples of programming languages we mentioned in our previous lessons, which of them fall under compiled languages and those under interpreted languages? Now, if you remember, we mentioned of C, C++, C#, Java, C, C++, C#, Java. These are programming languages that are compiled into executable files before run by the computer. That is to say, the source code that you create will be converted to another type of files and run by the computer. These are compiled languages. And then we have interpreted languages or scripting languages like Python, PHP, JavaScript, and VB Script. Python, PHP, JavaScript, and VB Script. They are interpreted in the sense that the source code that you create in the IDE will be the same thing that will be carried to the production environment. That will be packaged as software and distributed. Okay, so moving on, mentioning of source code as instructions written in files, then we can also refer to those files as source files. That is to say, a file containing a source code for a software program is also referred to as a source file. Okay, hope you got this section. Now, when after creating source code to make a software, programmers can decide that their source code are available to anyone who wants to use it. That is, you can get a copy of that source code, duplicate or replicate it, modify, extend it, extract paths based on the permissions available in that license. When this happens, we can refer to your source code as open source. On the other hand, if you do not want other developers to use your source code, then you can close it up. When that happens, we say we have closed source code. When a source code is closed, then it is prohibited for replicating, modifying, extending, extracting without notifying the original creator of those source codes. So with this part of our lesson, what I want us to understand is that source code can be available free of charge on somewhere in the internet. That is, you can get access to someone's source code, replicate it, modify it, extend it, extract path to meet your own needs. When a source code is available this way, we call it open source. Are we good? Okay. Now, earlier on, I made mention that a group of developers may be assigned to work on the same source code. That is, multiple developers may be working on developing the same piece of software. When that happens, we need a way to control this source code so that the developers can be able to track the changes that they make, then have a means to merge their different source code into a main one that can be converted into the software. Hence comes in source control or version control. This is a practice of tracking and managing changes to source code. And then a piece of software that helps in managing this exercise is what we call source control management system. A source control management system provides a running history of code development and help to resolve conflict when merging contributions from different developers or multiple sources. I know it's a bit confusing, but just keep track of what we are building on. We defined what a source code is. Then we made mention that a source code may be open for other developers to work on. We also said that multiple developers may be working on the same source code at the same time, intended for the same piece of software. When this happens, they need a means of tracking the changes each of them is doing, and then a means of managing their differences into a unified source code. From there, they can create the software. The system for managing this exercise is what we call source control management system. Okay, so now we have agreed that multiple developers may be working on the same source code. There comes in the next lesson. Git. Git. Git is a software for tracking changes in any set of files, usually used for coordinating work among programmers who are collaboratively developing the same source code. Are you getting the flow now? Okay, so what we are saying about Git is that source codes can be created by different developers, and at the end of the day, they will try to put them together to create the same piece of software. Git is a software that helps developers to be able to manage that exercise. Now, at this point, with that understanding, let's go to the Git website and download a version of that application on our system. We will be using it to manage our source code. When we finish installing and testing, we will come to know a company we call GitHub that provides free hosting environment for managing our source code. Yes, I know you were wondering, how can two developers working from different locations be able to merge their code? Then comes in GitHub. So right away, let's go and install our Git. When we come back, we will look at GitHub in details. Okay, so straightforward, we move to the Git website to download the application, and that is Gates hyphen SCM, Gates hyphen SCM.com will help. Okay, so this is the Gates web application where the Gates package is being hosted. When we look at what is before us right now, we have a brief message about what Git is all about. It says Git is a free and open source. You remember open source, meaning that the source code that was used in developing this Git application is also available for free. Distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Now, what we said about distributed version control, you may remember, is the same as source control. Now, distributed in the sense that each developer will have a cloned or a mirrored version on his own development environment. A cloned or a mirrored version on his own development environment. So the code is kind of distributed among the developers. Then at the end of the day, they try to bring them together to a main stream. They bring the various distribution together in a main stream. All right, so without wasting my time, we move to the middle right where we have this monitor. We see download for Windows. And just like we downloaded our IDE, the application has detected that I'm running the Windows operating system. So it's giving me the exact version that I need. When you scroll down a bit, you have other versions that you can use. This is for Mac, and this is the source code if you want to run on the Linux platforms. You can build it yourself. Yeah, this is the source code. This is the source code. So it's free. You can also download and look into it. And this is also for Windows platform, which is the same as this. So I'll go ahead to download this for Windows. All right. Okay, so it will take some time to be ready. It will take some time to be ready. Now, what if we are not getting the whole thing about Git? What we are trying to do is that we are trying to prepare our machine such that we can easily transfer our source code to somewhere in the cloud, and that whenever we want to work on that same source code irrespective of the machine we have, we can always get access to the code. We can always get access to the code. So the download is done. I think I'll use open from this option to do the installation. Okay, so this is the installation process. I already have it on my machine, but I'll go ahead and install it again so that if there are new updates, I will have as well. So this is the first page of the installation setup. I click on next, and then you have some options here you can go through, but for now I see something new here, meaning that it wasn't available when I had my previous version, so I'm going to add it to it. It will incorporate Git bash profile to my Windows terminal. I'll talk about Windows terminal very soon, so don't worry. Remove. All right. I just accept the default. I'm not going to worry my head with anything here. Yeah, Visual Studio Code is my default ID, so I just move next. Okay. I think with that aspect, I need to talk a bit about what is going to happen. Now, as I said, Git will help us to manage different versions, and then we will have a mainstream where all versions will gradually go into. And then if that is the case, then there is some name we need to give to various versions and the mainstream as well. Initially or currently, the word master was used to refer the mainstream. Master was used to refer the mainstream. And then now we are trying to move from using the word master to use the word main, from using the word master to use the word main. Others have some reasons as to why the change, but I think it's a change to suit the purpose itself. It's a change to suit the purpose because the various branches or the various codes that are on different machines and that of the mainstream are all on the same level, just that one is main and the other is branches. So using the word main to name it is more appropriate. So I'm going to change here to override the master so that I'll accept main as the name for the mainstream, the mainstream from which different developers can work and merge their code into. All right, now let's move on. Did I skip one step? Yeah, here I'm just going to accept the recommended. Okay, so let me accept the recommended and move on. Before and proceed. Yeah, we're also going to accept this and then just move on. Okay, so we wait for the installation. Okay, removing previous version. Yes, I told you I had a previous version. It needs to remove them and install the new one. That's cool. That's cool. Okay, so I need to launch the Git bash. All right, so this is to mean that you have Git running. This is a window where you can do your Git operations. You can perform your Git operation. Actually, Git as a software, you will not be having that luxury UI where you'll be clicking to get work done. Here, we will put our brain to work. Here, we put our memory to work. Now let's start the game. Git. Just type Git and press enter. A whole lot, let me maximize the window. A whole lot of guys will pop up. This is what we call command line interface. Command line interface. It is a kind of software that you can only interact with it, that you can only use using a command line, that is a black screen like this where you type the command. You type in the command. There's no icon to go and click. You type in the command to get the work done. For example, one says that the usage git, then you choose one of these commands. I can see git double hyphen version. I'm going to follow that to see what is going to happen there. Git double hyphen version. Okay. All right. So it gives the current version of the Git that I have installed. It gives the current version of the Git that I have installed. Usually for every software, there is some menu that says about. You click on about, then you see the version number, the version code and stuff. Git, or let me say command line interfaces, they are applications that don't have UI. They don't have user interfaces. They receive just command input. So whatever you want to get from the software, you must make a command input. So I wanted to know the version of the Git I have. So I needed to type the command for it. You may be wondering, okay, so this open window is the one you'll be working from all the time. No. With command line interfaces or CLI applications, it installs in the machine, and that any command line application can interact with it. So I'm going to try another command line application. Let me close this. Then I move to my start button and type command. Okay. On Windows, you will have command prompt. This command prompt is an application for interacting with command line interface, that is CLI applications. Now, Git must be available here too. So Git, do you remember the code for checking the version? Double hyphen version. Okay, so the version is also printed for us. The version is printed for us here as well. Now, those using the Mac OS or the Linux OS, you have it named as terminal. You will have it named as terminal. And those of Windows, you have another command line application called PowerShell. Okay, Windows PowerShell. Okay, so let me check Git in here as well. Git double hyphen version. All right, it's also doing the same work. It's also doing the same work. Okay, so these are kind of applications henceforth we will be using. Henceforth we will be using, especially to manage our Git and source code. To manage our Git and source code. All right, then you might be wondering, you need to open this window as well as open your IDE. Then you come there, you go there. Nowhere. The IDE also has an inbuilt terminal you can easily use. I'll call it terminal, I'll call it command prompt, I'll call it shell editor or whatever. Whichever way I use it, just know that I'm referring to this blue black screen with no icon. You only type commands. Okay, that's fine. All right, so let's move to our IDE to see the version it also has over there. Okay, so we'll open our work that we've been doing so far. And then this is where we left. We want to have an interaction with our command line. When you look at the top bar or the title bar or the menu bar, whatever you call it, the title is here, the menu is here, they are made together to the top bar. You see terminal here, terminal here. You click on it and you open new terminal, new terminal. Okay, so look at the coding arena. Below that space, you will see something open there, a new pane open there with tabs on them, with tabs on them. The number of tabs you have will depend on the number of plugins you have installed. When you see something here that you do not have, do not worry. Right now, what matters is the terminal. What matters is the terminal. Now, this is just a window to connect to one of your installed terminal. So as you can see, at the right side, it says it's connected to the PowerShell terminal. PowerShell terminal. So I'm gonna check for the Git version here as well. Git double hyphen version. All right. Okay, so our Git is ready and then running and waiting for our first command. We will have our first command in next lessons. We will have our first Git command in the next following lessons. Okay, welcome back from that short exercise. Welcome back from that short exercise. We went to the Git website to install the Git application on our machine, and then we open our command prompt or the terminal or the PowerShell, whichever you have available, to check the version of Git that we installed. To check the version of Git that we installed. Now, let's get to know GitHub. Let's get to know GitHub. All right, what is the story today? The story is about how developers manage their source code, how developers manage their source code, and that even when multiple developers are working on the same source code, how the management is done. When multiple developers are working on the same source code, how is the management done? If you are thinking what I'm thinking, then they will need a central place on the internet where they can merge their source code. Developers working from different parts of the world, they definitely need the internet to communicate. So, therefore, GitHub is an application on the internet or a hosting environment on the internet that allows software developers to merge their code on a central position. On a central position. So GitHub gives us a place where we can merge all the different source code that we are all working on into a mainstream source code, So let's call our different versions branches, kind of branches. So at the end of the day, we will all move into the stem, which we are calling the main stem. The main stem. Okay, so let's move to GitHub website. Okay, so you launch or open your browser. I already have it open here. So I'm going to add a new tab here. All right, then you head to github.com / github.com. All right. Okay, where the world builds software. Where the world builds software. So that's it. All right, so you're gonna create an account if you don't have one already. You're gonna create an account if you don't have one already. I already have one, but I'll go through the account creation process with you. You move to the right top corner, you see sign up. There's sign in here for those coming back, like myself. But for you, if you don't already have an account, you hit the sign up. So go ahead and hit the sign up. Okay. Hey, I like the welcoming message. Welcome to GitHub. Let's begin the adventure. Enter your email address. Enter your email address. Okay, so guys, you're going to enter your email address here and then et.encho@gmail.com. Okay. Then you're going to use the continue button at the right side. Let me select so that this goes away. You use the continue button at the right side. I already have account, so let me hit continue and let's see what they will tell me. Email is invalid or already taken. All right, so I already have an account here. Go ahead, follow the steps, and create an account for yourself. Okay, so that is it for GitHub for now. That is it for GitHub for now. Okay, so that brings us to the end of our lesson today on source code and Git management. Source code and Git management. Um, at this moment, we have also brought to an end the series Introduction to Web Development. This lesson also concludes the series Introduction to Web Development. It has been a very interesting journey, and then I hope you have learned so much and prepared for the journey ahead. I hope you have learned so much and ready for the journey ahead. In the next series, we're going to dive into HTML, CSS, and JavaScript. In the next series, we're going to dive into HTML, CSS, and JavaScript. I know you will enjoy it and you will learn a lot. Join me next time as we bring you HTML and CSS. HTML and CSS. For now, bye bye.